So hi and hello. Welcome to our channel named Algo Exploration. My name is Samir. Now in today's lecture we are going to solve a problem in which we have to find whether S is a subsequence of T. So let's take one example. Here let's say S is equals to A, B, C and we have T in which the T A, H, B, G, D, E. Sorry, G, D, C. Okay. Now here we can see that we have to tell whether S is a subsequence of T or not. Now, what do you mean by subsequence? Subsequence is nothing but a part of a string that too in a relative order. Okay, so let's say here we have A, B, and C. Now we have to find whether A, B, C are present in T or not. Okay, so we can see that A is present, B is also present, and C is also present, and that too in relative order. That means a, then B, and then C. Here also A, then B, and then C. Okay, so we can see that S is a subsequence of T. But let's take one more example. S is equals to A, B, C, and then we have T is equals to A, H, C, G, D, B. Okay, now here also we can see that in T, A is present, B is present, and C is also present. But we can see that in S, A, then B, and then C. But in T, we have A, then C, and then B, right? Here, this ordering is changed, right? So here we can see that S is not a subsequence of T. Okay, so if it is subsequence, then we have to return true. If it is not, then we have to return false. Okay, now let's see how we can solve this problem. Now let's talk about the brute force approach first. Okay, so here we have to find each and every permutation of this string. Okay, after finding each and every permutation, we have to match with this S. If it matches, then we have to return true. But let's see how we can find the permutation. So this is a very big string. Let's take one small string, that is X, Y, and Z. Okay, so this is a string. Now if we want to find the permutation, we have to see in one string X can be present, in one string X can be not. Here also Y can be present, in other string Y will not be present. Okay, so using this approach only we are going to solve this, but I'm not going to code this brute force approach, because I'm going to show you how to find the permutation in the later concept which we call it as a backtracking. Okay, so I'm just going to show you the idea. So let's say if you want to find the permutation, see in this X cannot be present, and in this X can be present. Okay, now if we are bifurcating with X, the remaining letters are Y and Z, right? So Y and Z, here also Y and Z. Okay, now let's go forward. Here we are going to talk about Y. So here Y cannot be present, and here Y can be present. Okay, now if Y is not present, then the string is empty. The remaining letter is Z. Here Y is present, the remaining letter is Z. If we talk about this string, Y cannot be present and Y can be present. So X, only X will be there, and the remaining letter is Z. Here X can be present and Y can also be present, right? And the remaining letter is Z. Now let's talk about Z. Z, Z, and Z. Okay, now if here Z cannot be present, here Z can be present. If the Z is not present, then the string is empty, final string is empty. If the Z is present, then here only the Z will be present, right? For this Z cannot be present, Z can be present. So for this Y only, and for this Y and Z. If you talk about this string, Z cannot be present and Z can be present. Okay, so X only, and then X Z. Similarly, here also Z cannot be present and Z can be present. So when the Z is not present, the final string is xy, and here if the z is present, the final string is x, y, and z. Okay, so we got total 1, 2, 3, 4, 5, 6, 7, 8. Why 8? Because as I said, x can be present, x cannot. Y can be present, y cannot. Z can be present, z cannot. Okay, so for every letter there are two choices, right? So there are total 3 letters, so 2 raised to 3 choices, that will be 8. So that's why we got total 8 permutations. Okay, now we have to check. Let's say the s is x, y, and this was t, right? Now we found out each and every permutation of t. Now we have to check whether sy is present in all these permutations. Now you can see that xy is present, so we can say that S is a subsequence of T. Okay, so in this way we can find out the answer using the brute force. But here we can see that we have to find each and every permutation. So this will be very, very huge. So let's say if the length of the T string is n, then this will lead to 2 raised to n for finding each and every permutation. Now for each and every permutation, we have to compare with this S, right? So for this S, let's say the size M. Okay, so M into 2 raised to n, this will be the time complexity, which will be very huge, right? So we are not right now going with this step, that how to code this to find the permutation, because I will explain this in the backtracking concept. Okay, so we are going to see another approach. This is a very simple question. See, here we have to find whether S is a subsequence of T. So we can keep a track. Here we will have P1 and here we will have P2. When P1 and P2 are same, we are going to move further. Here we can see that P1 and P2 are same. So let's move further. P1 will be pointing here and P2 will be pointing here. Now P1 is pointing at B and P2 is pointing as H. We can see that they are not equal, right? So since we want that S should be the subsequence, we have to move P2, not P1. Okay. Now again, we have to compare B and P2 is pointing on which letter, which is pointing to P. So we can see that they are equal. So move forward. P1 will be incremented and P2 will also be incremented. P2 is actually pointing to G now. Okay. Now P1 is pointing to C and P2 is pointing at G. They are not equal. Okay. So just move P2. Okay. Now C and P2 is pointing to D, right? They are also not equal. So move P2. Now P1 is C and P2 is also pointing to C. So they are equal. So move forward. P1 is here and P2 is here. When either of them are pointing to at the end, so we have to stop it. Okay, so this is the approach. So if we talk about the pseudocode, it is very simple. Here we have to take the help of the while loop. While P1 is less than n and P2 is less than m. Now what is m and n? The size of this S is n and the size of this T is m. Okay, initially P1 is pointing at 0, P2 is also pointing at 0. Okay, now here I'm going to show you with the help of the Java. Okay, so you can figure it out of your own programming language, C, C++, Python. If S dot character at P1 is equals to T dot character at P2, if they are both same, at that time we have to move P1 and P2 forward, right? So P1 plus plus, P2 plus plus. Else if they are not same, so in this case we can see that in this case P1 and P2 are not same, right? So at that time we are just moving P2 ahead, not P1. Okay, so else just move P2. That's it. Okay, So here we can little bit do the optimization, that in every case, see, in every iteration we are moving p2, right? We are incrementing the p2, and when both are same, then only we are moving p1, right? So you can do this optimization. If the condition is true, then only move p1, otherwise on every step move p2. That's it. Okay, I hope you got this. Now, do you think that the code is over? No, code is not over, code is still remaining. See, if we again have to check, let's say if the t is smaller but s is bigger, let's say s is x, y, z, and w. Okay, and t is equals to x, y, z, right? Now here in this case, p1 will be pointing here, p2 will be pointing here, both are same. P will move forward, right? And p2 will move forward, right? Here in this case, p2 is pointing at 3, and this will fail, right? So we have to move, we have to terminate the loop, right? But p1 is still pointing at w, right? So we have to check whether p1 is lesser than s dot length. If it is, then we didn't we got to know that s is not a subsequence of t, so return false. And if s is actually greater than length, s dot length, then return true. I hope you got this. Okay, so this was the code. Now if you talk about the time complexity, we can see that here there is only single while loop, right, which are running for n and m. Okay, now here in this case we have to find what is n and m. Okay, so n is nothing but this length of s, and m is nothing but the length of t. Okay, so we have to check at which condition while loop will fail. See, while loop will fail if any of them fails, right? So if any of them fail, it means that either n or m, if it is smaller, then only this while loop will fail. Okay, so if I say x is equals to minimum of m comma n, then the time complexity will be order of x, and the space complexity is order of 1. Okay, so this is the time complexity. I hope you got this. Okay, so if you didn't get, then I'll advise you to please dry run it by yourself. Okay, so that's it from my side. I'll see you in the next video. Till then, keep practicing. Thank you. Bye bye.